Hello students, myself Dr. Prakash Pitroda. Let us get into Java tokens part 2, understanding about other tokens. In our previous class we have learned Java token. We have understood it's the smallest unit of a Java program statement, where we have seen assuming that there is a statement int a equal to 10. Then we have seen is int is keyword. We've understood the meaning of keyword. They are reserved words, which has a special meaning for Java. We've also seen identifiers, which are memory addresses. In case you've not done, you should follow the part 1 first. Operators is the one which we are going to see in this particular segment. Literal, we have seen literal. They are the data values, the constants, which are useful to store into your program. These are your data, actual data on which your program works. We have seen that also. And punctuators or so-called separator, which will be dealing in another session. So today our session is going to be operators. Few of the operators will take into this session. Other operators will go into the next session. So let us begin understanding operator. Operator, the meaning is nothing but a special sign or a symbol. When you look at any expression, so if I'm going to apply an expression over here, okay, so let us say that there is an expression over here, say int c is equal to a plus b. Then you can say here is an expression part, all right, which is going to be a combination of you can say operator and the variable which are known as an operand. And we need to say that they are called legal expression, or legal you can say combination, because I could have also said c is equal to a b plus. That is also combination of a b n plus, which is a b n plus over here, but this is not allowed, this is allowed, so they are called legal. All right, so your expression is a legal combination of operators, that is the signs, and operand, which is nothing but the variable. So in this segment we are going to deal with the operators. So expression we have understood. Operand is nothing but a variable on which your expression works. So if I have to say that what is happening in this particular expression, then you will say there is addition happening because the operator plus is present over there. So you will be able to easily say what is happening in this expression with the help of sign. So operand is a variable on which these operators work, and operators are one which provides the meaning to the Java statement. So you can say operators are the special sign or a symbol which provides meaning to the Java statement. So what is happening in each expression, you will come to know using this expression. Now there are various types: assignment operator, arithmetic operator, relational operators, logical operators. You also have conditional operator, you have shorthand operator, you have increment decrement operator. There are many of them. Few we will definitely discuss in this session, and few we are going to be discussing in the next session. So let us say here the example you have seen, c is equal to a plus b, where a and b and c are your operands, whereas is equal to and plus sign are your operators. So let us see in the next slide. So there we go. We begin with understanding the meaning of assignment operator. Assignment, the word assignment, sorry, my mistake. The word assignment. So we are going to say the word assignment over here. Assignment is assigning a value. It assigns a value or an expression to a variable. So the operator over here is equal to sign. So when I say int n is equal to 5, it means in the memory variable, so inside somewhere, assuming here is the memory, then inside that num variable 5 has been stored. So whenever we call num, the value 5 is supplied over there. So sum is equal to a plus b. It means wherever somewhere there will be sum, all right, the value of a and b will be applied, the total will be done, and the actual value will be stored over here, which is supposed to be the sum of a and b. All right, so assignment operator is the basic operation, is to assign a value or an expression to a variable. Okay, it's going to be a very useful operator in doing all kind of mathematical operations and storing direct values. Then you have a second type of set of operators. Now this is a set of operators which we call as arithmetic operator. Arithmetic operators are going to be helping us to do the arithmetical calculation. It helps us to perform the arithmetical expression or operation, you can say, in a particular program. We know some of the operators. Plus is to perform the addition part, minus is to perform the process of subtraction, asterisk sign is to perform the process of multiplication, and division. Now very important that we need to understand, division is going to divide one number by another number. You will see the quotient part will be returned to us. So when I divide 15 by say 3, 3 5s are 15. Alright, so division is the only place where you will have two parts, the quotient and the remainder. So the quotient part, if you want to store, you use slash sign. So automatically x is going to store this part of the expression. So 5 is stored. And the last and the new operator from the programming point of view that we have is, one moment, is going to be your asterisk sign. So very important, you can say, operator over here. It's a new operator, so kindly pay attention. It's a percentage sign, which is also known as, somewhere it's written there, no it's not written there, then I would write here, the percentage sign is known as the mod sign, mod, or it can call modulus sign. All right, it returns you the remainder of the division, stores the remainder of the division. So when I say 15 slash 2, all right, and 15 percentage, that's mod, 15 mod 2, computer will divide 15 by 2 after the first nearest exact division. So 2 sevens are 15 is the nearest exact division. Now further, if I really need to go ahead mathematically, then I would generally apply a dot over here and I will put a 0 over here to start 2 5s are 10 is my further mathematical expression. But after the first nearest exact division, the remainder is 1. So when I say x is equal to 15 mod 2, I will get 1 stored into the memory. So if I say 15 slash 2, now remember, if this is integer, computer will only take integer divided by integer is the integer side of the answer. We are going to learn this particular concept further. Why is this integer divided by integer further in casting? There is this concept called casting where we are going to learn why this is happening. But as of now, conceptually you need to understand, if I take integer divided by integer, then computer will only give me the integer side of the answer, that's a 7. If I want a decimal, then at least one of them, either 2.0 or 15.0, at least one of them or both of them can be decimal. Now in that case, this part is supposed to be decimal. But when it comes to 15 mod 2, even if this is 15.0, 2.0, the answer is still going to be 1.0. It only takes into consideration the first nearest exact division. After that, whatever remainder that you have is your answer. So if this would have been decimal and this is decimal, this answer could have been 1.0. But it is not going to give you 0 fully. Alright, it is not going to go until the 0 division. The job of a modulus is to provide this. Okay, now what if I have 25 divided by 5 or 25 mod 5? 25 mod 5. So 5 4s are 20 is the nearest exact first division. My remainder is 0. Now there is a beautiful, very important logic coming behind this, that when you divide one number by another number and after the first nearest exact division, if the remainder is 0, then there is a logical relationship between these two. And what is this logical relation between these two? That I can easily say 20 is a multiple of 5 and 5 is a factor of 20. That's a logical relation, because after the first exact division, the answer is 0. Whereas in the previous case, after the first exact division, the answer is not 0. Hence, you can say that there is no logical relation between them. So now if I generalize this statement, that's where the logic lies. There are many good questions that has been framed in even in ICSE on this concept. If you are conceptually clear that if there are two integers given to you, any two, and if you take assuming the first one a whatever integer here divide by another integer using modulus, if the answer is return 0, this is not a computer program, so I have not used double equal to. If answer is 0, it means after first number divide by second number, if the remainder is 0, then definitely a must be a multiple of b and b must be a factor of a. Okay, or I can say 20 is exactly divisible by 5. So I want to see if a particular number is exactly divisible by another number, then I'll say a is a first number, modulus b is a second number. If the division is 0, then definitely first number is exactly divisible by second. If not, then there is no logical relationship. Okay, remaining we will definitely do a lot of programming on modulus in the future section. That time I will come back and revise this and then we'll go ahead. As of now, modulus returns a remainder. Let us move on to the next set of you can say um, operator. The next operator that you have in your kitty is relational operator. So relational operator, just a moment, I'll change the color of the pen over here so that we'll be able to see it better. Let us take the color as blue. So now relational, the word relation. All right, so when we want to see a particular relation means am I taller than my friend, am I shorter than my friend, am I older than my friend, am I younger than my friend. That's the relation that we are talking about, not brother, sister, mother, father. Okay, so when two values are given, we can compare these two values and see whether the relation is really established, what kind of relation is going to be established. So we will make a statement, computer is going to evaluate the statement and tell us whether the written statement written by us is really true or false. So computer will not tell you right, wrong, correct, all right, or false, all right, or yes, no. Computer will tell you true or false. Computer will tell you true or false. So we will make an establishment of relation between two operands. Operands are the variables. So between two operands, you create a logical relationship, and that relationship is returned by or is evaluated by the computer as either true or false. Now there are signs that you need to have: less than, greater than, equal to. So this is nothing but, in mathematics we say equal to, but here equal to because single equal to is already being done as assignment operator. So you can't use one operator for two different reasons. So here when you want to establish relation whether two numbers are equal, you use equal to. You have less than or equal to, you have greater than or equal to, and this is considered as not equal to. So when I make a statement 5 greater than 3, so we have made a statement as a user, or rather say a programmer. You are a programmer, you have made a statement. Computer will evaluate whether 5 greater than 3 is a true statement or a false statement. So you can look around and say, oh, fan is on, true or false. Tube light is on, true or false. Alright, so suppose I'm sure you have all have played the truth and dare kind of a thing. So there are only two options. Here also there are two options. Either the statement is going to be true or it's going to be false. So it's a Boolean kind of a return. So any conditional statement will either return true or false. So if I say print, computer will not print 5, but computer will say this statement is true. So on screen I will get only true as the answer. So if I say 5 less than 3 is a false statement, so return value is false. Equal to is written like this, 5 equal to 3. So computer will say it's a false statement because they are not equal. 5 not equal to 3 is a true statement because they are really not equal. 5 greater than or, so it is going to consider two things, greater than as well as equal to. See, either the value is greater or equal to, one of them. So 5 greater than or equal to 3 is true. Even if I would have said 5 greater than equal to 5, it would return me true because it's equal. Whereas here also 5 less than equal to 3 is false. However, if I would have said 5 less than or equal to 5, I would have got true because it is still equal to, is less than or equal to one of them. Now, since these values are going to be returned in true or false sense, I can store them into a boolean. If I say system.out.println x, then 5 greater than 3, obviously it is a true statement. So true is getting stored into x. So this is going to print true as the answer. Remember, these are all small letters. You cannot have small capital letter output. It will always be small letters. And even if you are asked to write output in the exam, you cannot write this way TRUE. Wrong. It has to be TRUE small only. Okay, even false like this is a wrong answer because F is capital. It has to be false. Okay, so you need to be very careful by returning the answer. So relational operator is helping us to establish a relationship between two operands, which will help us returning either true or false. Then we have the next set of operators is called logical operators. So here you have multiple you can say conditions. We have seen previously also, but yes, again for operators I'm revising. Logical operator. Logical operator will help us establishing a relationship between conditions, not one, more than one condition, two or more. So if I want to evaluate whether a number is falling between two values. So if I say I want to see whether the number is falling from 60 to 75 or 60 to 75, I'll be able to write equal to here. So including 60, including 75, I want to check whether my marks falls into this, then I can create this. Always remember, in if condition, this whole thing, this whole entire from here to here, all right, to must come to true or false. In order to get true or false, because there are multiple condition A, condition B, I can have and condition C and condition D, you have operators called and or. And of course, sorry, you will also have not. So what is and? And means when multiple conditions have to be followed. A very simple example, if I tell you, let's say you want to take part in the school a particular competition, and I will say if the criteria you have to be school student, okay, and you have to be below 14 years. Okay, then the criteria is this and this. It means there is, even if it is not written in the criteria, when the numbers are given, it means all these numbers have to be, all these statements have to be true to get you the admission into or enroll into a competition, or you are not. So you can say yes, I am a school student, but I am not below 14, I am 15, then you are not eligible. Somebody says yes sir, I am below 14, but I don't go to school. India, a lot of people don't go to school. So you are also not eligible. Somebody says, sir, I am neither, like me, I am neither a school student nor below 14. So I am not eligible at all. And somebody says, yes, sir, I am a school student and I am below 14. So if I consider them as condition A and B, I can apply here. So condition A, if I say I am a school student, I'm writing just in English, not a computer part. In computer, there's a method in which manner in which you write. So if I say school student and my age below can be written less than 14. Okay, less than 14. So now if I say condition A false, it means I am not a school student. B false, it means I am not a student below 14. So I do not get admission. I do not get enrolled. Now I say yes, I am a school student, but I am still not below 14. I still do not get admission. Now I say I am not a school student, but I am below 14. I still don't get eligibility to participate. But if I say if I am a school student and I am below 14, I am able to participate. So this is how multiple conditions. So in order to participate in a competition, there are two conditions. There can be 3, 4, 5, 10 different conditions. Similarly for a number also, if a number is to be checked, whether my marks, assuming marks is a variable, if I want to see whether the marks is between from 60 to 75 including equal to, then assuming that say my marks are, let's say 65, then come marks value is 65, then you apply wherever mark 65 greater than equal to 60, true. So this is true. And so and in computer is written as 2 ampersand sign, you can't write a and d. Marks less than equal to 75, so 65 less than equal to 75 is also true. So true, true and true, true and true makes the whole condition true, so computer will be able to provide yes, you got a first class. Okay, so when multiple conditions are there, you can have and, you can have or, and you can have, we'll see or and not later on, but I hope you have understood. I can have multiple conditions with and. I can say if condition 1 and condition 2 and condition 3, this is one proper condition, full logical operator, a variable operator and a value, and a variable operator and a value. So this is how you can apply a logical operator. Establish a logical relationship between two conditions, two or more. I can have more. If there is a third condition, then also when there is an AND operator, logic is all conditions must be true to get the final output true. This whole thing has to be true, then both have to be true. If one of them is false, if one of them is false, if this is supposed to be false, if one of them is false or both of them are false, the entire outcome is false. So he says in case of a logical operator and, when outcome of all the conditions are true, that is here, then the final evaluation is true. If any one condition is false, then the final evaluation is false. So I hope you have understood this. Let us move on to the next one, OR part of it. So here again OR. In OR at least one. It says in case of logical OR is written with two standing lines. Two standing lines is just above your enter key, return enter key. Just above that you have a key which is looking somewhat like this. So this is a sign, okay, which is supposed to be used with shift. So these are two signs together, which is an OR. OR means any one. So if I go to a restaurant and says, give me a cold drink, Pepsi or thumbs up, assuming something is there, Pepsi or thumbs up. So if you have Pepsi, give me Pepsi. You have thumbs up, you give me thumbs up. All right. You have both, give me anything. It's like that. So OR is something which is very important. All right. So it will help you when two or more conditions are there and even one condition is true, the final evaluation should be true, then we use OR. So it says when one or all conditions are true, then final evaluation is true. If only when all the conditions are false, the final evaluation is false. For example, let us say here, now I want to see marks. Anybody can enter a marks below 0 also, because when I say input marks, entry can be any number. User cannot have a control. You cannot have a control over user. So if a user has put -5 marks, then it is less than 0. Or user has by mistake made 100 plus marks. So you can control your program by this. Either marks are below 0 or the marks are greater than 100, then we'll say it's a wrong input. So here what happens is at least one condition has to be true to get the output true. If all of them are false, then only the answer is false. Alright, so in this case you will find that for example, let's say my marks are say 75, then you will say 75 less than 0, false, or 75 greater than 0, false. So false or false is false, so this condition, this statement will not get evaluated, so automatically invalid won't come. You will get some other condition which will give a particular amount kind of a grade. Whereas in this case, if I say and the number is, let's say by chance 105, by mistake 105 is typed, 105 less than 0, false, but 105 greater than 100, true. So computer, false or true is going to be true. So there are many conditions where you will see where all are true or one of them is true. So true or false is true, false or true is also true, true or true is also true. But when it is going to be both are false, all are false rather. Alright, I can put this cross, of course. All are false, automatically your answer is false. So this is what you have for the OR. So you need to use it very systematically and rationally, this particular operator. And the last operator is a negative way of saying something, inverted operator. Something that will help you understanding or rather than negating the output. I want to continue until a particular button is not pressed. For example, if Q is not pressed, I don't want, computer shouldn't quit. Any other button you press, it should continue. So sometimes something is spoken in a negative way also is useful. For example, if you look around in your house, you may find a switchboard. Alright, and you may find some of the switches are on, some of the switches are off. So can I say the switch which is, one moment, I'll just take a pen here. The switch which is on, can I say it is not off? Means same, because they have only two choices. So even in true also, something which is not true means false. Something which is not false means true. Not will negate, invert the output of your condition. Alright, so somewhere in the programming we will use this in future, but you need to know that whenever a not is applied, it is applied not on a number. I cannot say not 5 greater than 3. This is invalid. Alright, because not cannot work on a number. It will work on a complete condition. So outside the bracket, you have to make a bracket, and then so 5 greater than true is a true statement. Not will apply. So not true means false. So if I say here system.out.println, if I apply here and I say what is the output, then you have to say output is false. So 10 less than 7 is a false statement. 10 less than 7 is not a true. It's a false statement. But the moment I say not of 10, no, how do you say? You say not of 10 less than 7. So 10 less than 7 is false. Okay, so not false. Not false means true. At some stage you will say as long as you do not press Q, program should continue. So we will see when we will apply this logic, this particular operator in our condition. Alright, so let us see if any other operators are left. Alright, so I hope you guys have understood this. We are going to continue with the next session. The part 3, we are going to learn increment, decrement operators, shorthand operators, and there are other operators which are left. I hope you have understood this. Until then, thank you very much everyone. God bless.